morning, everyone. I represent Munga River Limited, a nationally owned company. We've been around for over 10 years now, and we keep shattering the uncharted waters with a different perspective. I'm presenting the project is located in Mount Hagen. It's potentially a porphyry copper gold system we've identified. My presentation outline is location and access, in the history, the geology, the structural focus, a bit of geophysics and the prospects that we have generated, and final remarks. As you can see from the map there, the project is located within the fertile porphyry copper gold belt. And if you will find some favorable structural focus and mineralization and alteration in outcrop, it is worth pursuing it because you are in the right place and you can't go wrong. Bandagan project is located about 35 kilometers north of Mount Hagen in the Western Islands province. And it's got two separate tenements. It's contiguous, and each tenement is about 30 subblocks for a total of 103.2 square kilometers. So in total, we have about 206.4 square kilometers. It is access road, silt road up to Kotna, and also to Tigi. So, but death roads running through, two death roads run through the prospect. It's accessible by four-wheel drive vehicle now. And a helicopter takes about 15 minutes to reach the furthest outcrop from Mount Hagen Airport. When you say international airport, it takes direct flights from Australia and overseas. And we have access road to Lae, and 1 hour flight from Port Moresby to Mount Hagen. All the major projects to the west, including the Pogra and the oil fields, and even Frida River, they have a logistic one-stop point in Mount Hagen. Historically, exploration work started in the 1960s with BMR, and then ESO and City Resources. And GeoMap did some stream sediment and Fugo airborne geophysics in 2006 to 2009. In gold exploration spent a fair bit of time from 2009 to 2018. They collected a lot of samples and drilled about over 12,000 meters. And they exited in July 2018. And from then on, we moved in and we did our own exploration for the last 10 years. And we've collected a total of 824 samples over this period. And the results, I'll just present them in the next project, but I believe in exploration, if you really look at the surface outcrops and this kind of things, it's really a smoke. And if you get some high grades in there, these are sparks. And it must be coming from a fire and a humber at depth. A bit of geology here. Overlying country rock is upper Triassic-kind volcanics, and lower to upper Jurassic sediments. And within the thrust belt, we have low not dipping thrust faults. And we have this major structures, the Bismarck Fault, northwest, southeast, and further to the northeast, you have the Jimmy Cole Fault, and in between you have a couple of several northwest trending structures, and They're intruded by the mid to upper Miocene to Pliocene Kimmel diorite, intrusions of Kimmel diorites. The northwest southeast faults, they provide the Loki for northeast dipping transfer faults that dip to the south. And I believe these are the ones that localize major magmatic intrusions at that. On a regional perspective, I guess you can see we're in the fertile mineral belt, mid to upper Miocene intrusive magmatism, northwest, southwest, northwest to southeast arc parallel structures, northeast to southwest arc normal transfer faults, hosting world-class porphyry, copper, gold, and epithelial deposits. And we cannot go wrong if you are right inside the structural region. These are some of my my mapping and the structural focus. Locally, I consider that to be comparable to my structural focus that I've identified is comparable to the Lepanto project deposit in the Philippines and the Frida River project towards the west. And you can see the Limnos Roots fault and the Frida River fault. And in between, you can see that kind of undulation, kind of a setting in which the Frida ore deposit is deposited. And also, if you look at the Lepanto deposit here, the North Fault and the Harbor Fault, and in between, you have a kind of undulation setting in which the ore deposits are localized. And in Mount Hagen, where I am, you can see the two major faults that are on the Pug Fault Zone and the Port Pana Fault Zone. They are on the map up there, and in between there, you have the northeast southwest dipping striking and the southeast dipping, two parallel fault zones, and in between there I have intense mineralization localized along this, and I think I have the structural focus, and that's why we spend a lot of time doing our exploration there. A bit of geophysics from work by Harmony and matched with the Fugger data. You can see a circular feature there on the west side, and that also where our project is also most of our high-grade outcrop discoveries are located out there, with copper grades going as high as above 1%. If you can see the concentration of it, and also shows the historical drill holes. If you look at it, we are 1 or 2 kilometers away from where the historical drill holes are located. And the kind of donut-shaped kind of magnetic feature, it probably represents mag destruction. And on the map, we've located a lot of hematite and specular hematite, which is probably evidence of that. The porphyry copper potential is greater than 50% of our 824 rock chips we've collected. It returned above 0.05% copper, and 21.48% of rock chips collected returned greater than 0.3% copper, and 6.43% of the rock chips, total rock chips collected, but 0.2 to 0.3% copper, and 18.1% of it, 0.1 to 0.2. So more than 50% of the rocks that we've collected on outcrop, they return values that, copper values that are highly anomalous. And you can see the concentration there on the prospects that we have generated. That's anomalous values in zinc. We've also, from our map, we've noted the and metal zonation on the peripheries with lots of high-grade zinc, but then as you go back into the copper zone, zinc kind of falls away, and that indicates to us that the metal zonation of a porphyry system is, at least we've got some kind of a vector in there that gives us a clue and a direction to that. And molybdenum grades are too very good. Oh yeah, that's molybdenum. The peak value that we have received from outcrop is 0.4%. That also indicates to us that that's one of the projects that we have now centered on. It's Maragubi West. It's about 1K by 1.5K, and the dimensions of it is huge. 3 major prospects have been discovered, and all porphyry, copper, gold, defined by outcrop, alteration, and mineralization. And it's located 2 to 3 kilometers away from historical tested areas. More exploration work carried out over Maragubi prospect, where the red square is. And that's our Maragubi West prospect, and the trenches, and it's right on the top of the mountain. It's just a 500 by 400 meter area open in all directions at 2,400 meters. Close to the peak of the mountain, we've got acidic alteration with both supergene, hypogen, copper, molybdenum, and zinc mineralization. 2 types of potassic alteration have been noted: NEK feldspar, biotite, pyrite, trace chalcopyrite, followed by secondary biotite, magnetite, epidot, chloride, K-spar, albite, with pervasive chalcopyrite, bonite, and pyrite, and saprolite. Country rocks with strong anomalous silica replacement, alteration, mineralization, in the volcanics and the sediments. Trench 1 is over 80 meters continuously pervasive disseminated mineralization. Trench 2, 8, and 9 rock replacement, alteration, mineralization caused by magmatic hydrothermal potassic alteration. I-10 copper geochemistry, as you can see our trends here and the copper results, and some of our outcrops on this trends here. That's an hypothetical kind of a conceptual model here over this area. It's got about 2 kilometers and about over 4 kilometer, looking northwest, over 4 kilometer area. You can see the at 2,400 meters RL down to 1,200 meters. You have a vertical height of about 1 kilometer, just over 1 kilometer. And you can see the fault zones, the 2 fault zones, Fault Panda and Mulgreen fault zones there, and in between that, I believe the veinings and these things are typical porphyry types that we have uncovered, and the grades also speak for itself. And that's one of the fault zones, highly silicified. We couldn't break the rock, so we just had to apply fire and need to open it up to crack it. And that's what it shows in the rocks and location of the rock on that conceptual section there. Again, potassic alteration with granular quartz at the lower RL and copper grades. And we think we've got something that's interesting in terms of when we have proper potassic alteration, it signifies a kind of a porphyry system. Chalcopyrite with 12.7%, 3.2%. That's again when you go down to the lower RLs, the vein morphology and with increase in temperature and mineralization. Let's say magnetite is also coming into the picture with epidot, and that signifies kind of our observation that we have a proper system there, and associated with the fault zone and structures. That's our fault zone. Again, bonite and high-grade copper as well in one of our outcrops we've located, plus and then magnetite, chalcopyrite perhaps in it, and also associated with the system. So the hypothetical cross-section AB looking northwest, Castro, Maragubi West, and Rank prospects. as it is indicated on the other side. And I'm only concerned about the area in the red square, and the fault zones are both leading southeast, and then deep into the hill, southeast leading fault zone, deep into the hill as well. And southwest side of the hanging wall, southeast side of the hanging wall is southern by fracturing, thereby enhanced favorable porosity and permeability. Mineralization is mineral impregnated magmatic and hydrothermal fluid upflow, mixing with meteorite waters, cause precipitation and mineral deposition. Intense surface alteration and mineralization confirmed by I-10 geochemistry and porphyry copper style alteration vectors. 1.5, the area that in the red square is, dotted square is about 1 kilometer by 1.5 kilometers surface anomaly with potential depth of about 500 meters. And if you get a special gravity, say 2.5, you're likely to have about, 1,870 million tons at 0.4% equivalent. You could potentially come up with 7.5 million ton copper and located within so close to existing extraction fracture. And then if you look at the grade of the cut-off grade could potentially be highly enhanced and reduced if you are so close to existing access infrastructure, and that would enhance your economics of a project. The other thing that we have is the mineralizations that we are seeing is on the surface, and with a high elevation, you have a potential that waste to ore stripping ratio, and that could be potentially like a open cut mine, then underground or kind of a strip waste ratio, economic terms that cannot be favorable in this sense. But the location we have is this one is also another. As you go down to the lower RLs, you come into hematite, magnetite, and chalcopyrite in our trends outcrops, and this also signifies that's at around 1,600. So coming up from 2,400 meters, coming down to 1,600 meters is quite an elevation going down, but about 800 meters. And this one set down right down at 1,200 meters RL in the section, conceptual section there. And the mineralization is hosted by the volcanics and breccias in this one. And the grades are also quite significant, but in the areas that these prospects are located is 1 kilometer to 2 kilometer in area, square kilometers, 1.5 by 2 kilometers in area. This is an area that's volcanic hosted mineralization, volcanic breccias, basalt, dacites, rhyolites, and its dimension is 1 kilometer by 1 kilometer. That area shows the whole project, Maragubi project area. And the geochem tells you where all our prospects are. So in total, we have 3 prospects here. Each prospect is about, in dimension, is about 1 to 2 kilometers per kilometer, 1 kilometer by 2 kilometers. And then we have a road running through access road running through the prospects. And that's why I haven't picked up prospect. This one has got intense alteration, a lot of paraphyllite and kind of more like an advanced sulfuric alteration to philic alteration, but with a lot of supergene copper salvage like chalcocite and covalite and that. And if you look at it, the extent of it's about a kilometer, over a kilometer, and it's about 500 meters wide. Still, we're doing exploration work, and these are all surface indications. Again, these are some of the outcrop samples with the geochem. and some of our outcrops and trenches there with the geochem. The highest we have is about 13.5%. Okay. And then that's another porphyry system to the further to the north with the high-level porphyry intrusion in outcrop and a bridge here at the center of the prospect. And we've got some epithermal gold targets and we've discovered at Gans and Munga. We think there's a northwest-southeast trending structure of 138 grams, 28 grams, 79 grams in gold and epithermal targets there. Locals doing artisanal mining. And our epithermal veins with the gold grades for information. And the take home is like, it's all in there, it's like what we're doing is on the surface is all smoke and sparks. The amber and the fire, you will only know when you do the drilling. Thank you very much.